Welcome to the Numpy section of the course. So we already arrived at the Numpy. So to give you a brief introduction to Numpy, Numpy is the fundamental package for scientific computing in Python. It is a Python library that provides a multi-dimensional array object, various derived objects, and an assortment of routines for fast operations on arrays. So, including in NumPys are mathematical, logical, shape manipulation, sorting, selecting, Fourier transform, basic linear algebra, basic statistical operations, random simulation, and much more. So, another introduction to NumPy, it is a linear algebra library for Python. It is important for data science, for the reason that most of the libraries in the PyData ecosystem rely on the NumPy as their main building block. So NumPy is already included in the Anaconda distribution. If you installed the Python using this Anaconda distribution, the NumPy is already included. So to use NumPy, you don't directly use it, but you use the keyword import. So for example, before using the NumPy, you want to import the library first. So you type import NumPy, NUMPY as NP. So this NP is whatever name you like, but as a practice, if you see tutorials or any website tutorials in Python, they name this as NP, so we will stick to NP. Okay, so then we execute the code. It just means that the NumPy library is being imported to this specific notebook. Okay, so let's start with a NumPy array. Let's create a NumPy array through casting a list. So for example, I have list 1. So again, so we have 1, 2, 3, 4. So we're trying to create a NumPy array through casting a list. Okay. So for example, we have array 1. Okay, equivalent to NP. So NP here is our NumPy. Then we will use the methods of array. So let's say list 1. So this means that we have a NumPy array. Yes, we see the value of the array 1. So this one is array which composed of 1, 2, 3, 4. This is a single dimension array as denoted by a single bracket. Okay, so how about we create a multi-dimensional array? So how can we create a multi-dimensional array through casting a list into a NumPy? For example, I got here another list. So the double bracket denotes that I'm going to create a nested list. Okay, so 1, 2, 3. Then for example 4, 5, 6. Then we have 7, 8, 9. So let's execute this one. So my list. Okay, so how about we convert it to array? So for example, NP array, we're using the array method of the NumPy. So array, then my list. Okay, so let's see the result. So I will use Alt Enter so as not to overwrite this np.orange markdown. Okay, so we're creating here a two-dimensional array. So as denoted by the double square bracket. Okay, so this is a two-dimensional array already with 3 rows and 3 columns. So this is a 3 by 3 array. Okay, but this is not the way to do it if you are going to create an array. So let us discuss several functions or methods for the NumPy array. So first one is the np.arrange. So the np.arrange, it returns evenly spaced values within a given interval. So for example, we use the np. So this is your definition for NumPy. So let's say arrange. Okay. So how about we supplied it with a singular parameter? So for example, 11. So what this means is you're creating a single dimension array from 0 to 10. So again, the 11 is exclusive, not included. So it's from ranges from 0 to 10. So another one is you have two parameters. So for example, I want to create an array from 5 to 10. Okay, so I'm creating from 5 to 10. So this is a single dimension array with lower bound of 5 until to 11. But again, this is exclusive. So it's already, it is ending at 10. Okay, so 11 is not included. So let me just alt enter to create another line. Then you can pass three parameters. So for example, np arrange. For example, 0 to 10. Then this returns equally spaced value according to its definition. So how about we supplied a 2 value. So alt enter. As you can see, we're displaying a single dimension array with items. Okay, at the inside which is equally spaced into the value of 2. So for example, I have changed this. So 0 to 10 equally spaced at 5. So for example, shift enter. So it will be 0, 5, 10. So if you made this how about a decimal number, for example 0.5, so it will extend the size of the array. So as you can see, this is equally spaced at 0.5 until it reaches 10.5. Okay, so that is equal spacing. You use np arrange for equal spacing. But if you do not want this decimal point, let's say how about 3, so the size of the array will change depending on the equally spacing value that you provide. So this just means from 0 to 10, equally space it into 3. So 0, 3, 6, 9. So that's the definition for the numpy arrange. Okay, arrange. So return evenly spaced values within a given interval. So the next one is we have here another which is np0. So it's just return a new array of a given shape and type filled with zeros. So for example, you define np0s. We have parameter of 3. So it will define a singular dimension array which composed of zeros. As you can see, we provide 3. So we have singular with 3 items. So how about you provide another parameter? So for example, np0s, I want a 3 by 3 array, okay, which is composed of 0. So I'll enter. So np0s, I think I got an error here. Okay, so what my error here is that this should be a tuple. Okay, the definition. Okay, we pass a tuple instead of just a simple parameter. So Alt enter. So I've created here a 3 by 3 array which is composed of 0, which is that's the definition of zeros. It returns a new array of a given shape and type filled with zeros. Okay, so that's a method. Of course, we have also ones. So same thing. So we just copy here. So if we copy here, it will just generate ones. Sorry about that, I did not change this one. So instead of 0, it will generate 1. So for example, I have copied this one. So how about a 5 by 5 array? But we have a value of 1. So again, this is our tuple. Okay. So sorry about that. So Alt enter. So we created a 5 by 5 array with values of 1s. So let's remove the excess cells. Okay. So we just saved. So another one is np.linspace. So np is numpy again. So it returns evenly spaced number over a specified interval. So what linspace means is, let me just demonstrate it to you. So np.linspace. So from 0 to 10 will generate. Then the third argument is the number of points that you have. Okay, so these are evenly spaced numbers over a specified interval. So I've selected an interval of 5. So let's see the result. So it is, as you can see, from 0 to 2.5, it has a interval of 5. Why? So we have point 5, 1, 1, 5, so 2, then 2.5. This is equally spaced with an interval of 5. Not necessarily numerically 5, okay, but we're concerned with the interval. So another example, so np dot, for example, is linspace from 0 to 30. So about 0 to 30, and how about I want a 10 interval values from 0 to 30. Okay, so from 0 to 30, we have 0, 3.3, 6.66, 10. So remember, these are equally spaced intervals before I reaches the number 30. So that's Linspace. Okay, so another one is the NPI or the Numpy I. So it returns a 2D array with ones on the diagonal and zeros elsewhere. So this is just similar to if you are doing identity matrix. So the diagonal in the matrix is composed of ones. So we use the np.I. Okay. So how about we create a 4x4 array with ones at the diagonal. So Alt Enter. Okay. So as you can see, we have 1 at the diagonal. So if you're creating an identity matrix quickly, so this is the numpy I is your probably your choice. Okay, so if you made this one a bigger value, so you have also a bigger matrix. So as you can see, the diagonal one is composed of ones. So these are identity matrix. Okay, let's move ahead. So about np random.rand. So it returns values which is random in a given shape. So for example, so I have np.random.rand. So I will create a single dimension here. For example, 5. So I'll enter. So these are random numbers produced. So it changes. So for example, I hit enter again. So since we define a random number here, so the number results, you can predict this one because it's a random number. Okay, so it changes over time. So these are just a single dimension if you provide a single parameter. What if you want a 2 by 3 matrix? Okay, so random 2 by 3 matrix. So it will generate also a 2 by 3 matrix with random numbers. So to confirm that, I will execute this again. So shift enter. Okay, so notice the value, it changes because we are doing a random number here. So another one is we have numpy random rand n. So it returns a sample or samples from the standard normal distribution. So the item in the matrix are at the standard normal distribution. So for example, let's do this. How about np dot random dot rand n? So we'll create a 5 by 5 matrix. So the item here is equally distributed from the standard normal distribution. Okay, so it's a linear algebra. So that's why a numpy is a linear algebra mostly. Okay, so another one, we have a np random.randint. So it returns random integers from low, which is inclusive, then to high, which is exclusive. Okay, so let me give you an example. So np, for example, we have random, then we will use randint. So from 1 to 20. So this just means that we want to generate a random number from 1 to 20. Okay, so the value here is just so the result is 5. But if I execute this again, so since again this is a random integer, so it changes. So basically it just select a number, a random number from 1 to 20. Okay, so including 1 and 20 also, which is the integers from low, which is this is inclusive, then 20 is not included because the ruling says that it is exclusive. So it's 1 to 19 only. Okay, so we're generating a 1 to 19. Yes, 1 to 19. So we're lucky we generate the 19th number. So for example, how about we provide 3 parameters, for example. So np rand int, how about from 1 to 10? Okay, so we passed a 5 number. So this just means that we would like to generate 5 random numbers from 1 to 9. Okay, so this is a discrete uniform distribution also. Distribution. Okay, so shift tab. Not shift tab, shift enter. Okay, so we from 1 to 9 we want to generate 5 random numbers. So again, these are Numpy array. So again, this one changes because we're generating random numbers. Okay, so another important function for Numpy, it is the reshape method. Okay, so this just gives a new shape to an array without changing its data. So for example, I have a random array. So let's create a random array. Okay, equivalent to np dot random. Let's generate random integer. So rand int. So I want to generate from 0 to 50. Okay, but we have select from 0 to 50 25 only random numbers. So again, I will use alt enter. So if you want to take a look at the random array values, so alt. So we generated 25 numbers from 0 to 50, actually 49. Okay, so how about what's the function here of the reshape? So I can reshape this one, so same value but different structure as a matrix. So for example, so we have a random array dot reshape. So this is a 20 composed of 25 items. Okay, sorry for the wrong spelling. So reshape, how about since this is a 25, we can do 5 by 5. Okay, so you convert this into a 5 by 5 matrix. So alt enter. So same value, as you can see, 23, 4, 0, 24, 43. Okay, that's the first row. Then 32. Now these are multi-dimensional array already. As you can see, we have a double square bracket at the beginning. Okay, this is a multi-dimensional array. So we use the reshape. Okay, so how about we reshape it unevenly? So for example, 5 by 10. Can you do this? So we'll alt enter. So it will reshape an error because it cannot do 25 items into 50. Okay, so the only possible here is 1 by 25. So these are the possibilities. Okay, and we also have 25 by 1. So this just means that we have a 25 row and a single column multi-dimensional array, but I like it 5 by 5. Okay, so this looks like a matrix. So also, so let me just remove this one, so delete. So also we have also the array methods. For example, the max and the minimum. So for example, I will create a random array again. So random array, numpy, again random int. So rand int. So from 0 to 25, I want to generate 10 numbers. So Alt enter. So let's see the random array. What's the value? Okay, so 4011 and so on. So we're using here the max function to identify what is the maximum value from the generated random array. So for example, random array dot max. So the result will be 23. As you can see, 23 here is the highest. Okay. So the opposite, which is the mean. Okay. So what will be the minimum or the lowest number in this array? So 0. So it agrees that the 0 is the lowest one. So we have also the argmax or the argmin. Okay, so let me just copy this one. So let's create another random array here. Okay, so Alt enter. So let's see the result. So random array. So the result is 11 to 23, 20, and so on. So 10 numbers from 0 to 25, actually 24 only. So the argmax identified the index of the max. So instead of identifying what is the highest value, it identifies what is the index of the highest value. So for example, so we got a random array, then we use the argument max. So the result will be 4. So let's count. 0, 1, 2, 3, 4. So 24. At index 24, you will find the highest value inside the array. Okay, we also have the argmin. So just the opposite one. We have argmin. So we have 8. We found the lowest value at index 8, probably this one. Okay, which is 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but index 8. Okay, so let's move on. So we have also the shape. The shape identifies only the shape of the vector. So for example, I got a random array shape. So let's identify the shape of this random array. So for example, this one. Okay, so let us execute this once again. Okay, so we have how about random array dot shape. Okay, so don't be confused. This time we won't be needing here the parenthesis. Okay, so we have a shape. Shift enter. So it's a 10 single dimension array. Okay, so how about we reshape this? So we reshape this. Okay, so we reshape this one. So for example, we have a new array equivalent to our random array. Okay, then we reshape. So this is a single dimension array with 10 items. So we can reshape this as 2 by 5. Okay, multi-dimensional array. So Alt enter. Then let's look at the new array. So basically we're just reshaping. Okay, from 725, 60, and 17 down to a single line. Now we're reshaping the Numpy array into 2 by 5 dimension. Okay, so it means we have 2 columns, 2 rows, I mean, and then we have 5 columns. Okay, so we can also identify the data type of an array. So for example, we already declare a new array at other cell. So new array.dtype. So let's see what is the result. So that's the value inside the array is integer, 32-bit integer. Okay, this is the first part of our lecture on Numpy array. So the next lecture will be the second part for the Numpy. So see you in the next lecture.